Hello students, welcome back. We just completed one domain problem from here. We have several more. Let's see, we just completed one problem. Looks like there are 3 more problems to go. Let's complete this one, and then if time permitting, this one as well. Almost certainly we won't be able to do this one, so I'm going to leave this one to students. Okay, let's go to the second problem. Let's open up Desmos graphing calculator, and here's a numerator, 5x squared plus 3x minus 2 plus, and then click this button to open up more keys. So square root button, okay, I don't need this anymore. And then 9x to the 6th power plus 8x to the 4th power plus 1. Right, get out and close parenthesis, go to the denominator, parenthesis open, 2x cubed minus x squared minus 3x. Okay, all right. I guess I got everything correctly here. Please check. Okay, here's a graph. What do you see? We have 4 curved pieces, apparently, separated by 3 vertical asymptotes. One here around x equals to -1, I guess, and then x equals to 0, and one around here around x equals to 2. No, and there I have crossing, so maybe 1.5. So we have 3 vertical asymptotes, so no y-coordinates there, so we have parentheses, and then 4 curved pieces. So the domain must consist of 4 open intervals, like this. Like this. So we have 3 vertical asymptotes, x equal to a, x equal to b, and x equal to c. And then my reasonable guess here is around x equals to -1, 0, and then about 1.5. I'm a little bit less certain about the third guess, but these two I'm reasonably certain simply by looking at the graph. You see, I didn't do any algebraic analysis. Just by looking at the graph, I made this reasonable guess. Okay, let's check. Here's the algebraic expression, and there are 2 things to remember. Inside of any square root has to be non-negative, any radical actually, and the denominator should not be equal to 0. Okay, square root first, but then again that'll turn out to be, by the way, here's the graph. Same as before, roughly speaking. Inside of the square root is always positive. We have even powers only, so positive all the time, no problem there. The square root is always valid, so it doesn't really do a thing as far as the domain is concerned. The denominator, on the other hand, you have to be a little bit careful here because denominator should be valid, which means that should not be equal to 0. So set the denominator equal to 0, solve it. By factoring, what do you get? You get x equal to 0, -1, or 3/2. Do you see that? So expunge those 3 numbers out. X equal to -1, x equal to 0, x equal to 3/2. Get those 3 out. And those 3 numbers divide the number line in 4 pieces. So we have these 4 open intervals. Compare that with your initial guess. Do they match? They match precisely. Even 1.5, that corresponds to 3/2. Yes, they match precisely. Okay, we went through 2 problems now, but those were exceptionally easy problems. Previously, we went through a problem that you have denominators to, you have the radical to consider, but the denominator did not contribute because it never hit 0. This time, we have denominator to consider, but the radical was always valid, so it didn't do anything. Maybe we have to consider a problem that both of them contribute. Well, here's one such problem. All right, we have a radical here. Inside of the radical is greater than or equal to 0, and entire denominator is not equal to 0. We'll have to consider both of them. How about the graph here? Okay, all right. Y equals to x plus 1, that's the numerator, and the denominator is 2x minus 4 plus, I need this square root, and then x squared, 3x minus 4. Okay, here we go. Please check if I copied everything correctly. All good? Okay, here's a graph. What do you see? Let's zoom out. Okay, just as usual, we have these three pieces, but no vertical asymptote here. We have abrupt ending, which means y-coordinate is well defined. Function value is well defined. So this value here, x equals to presumably -4, must be part of the domain. Same goes here, abrupt ending here, so y-coordinate is well defined. We have the function value, which is presumably -1, and then that begins from x equal to 1. But then again, we have vertical asymptote here. Is 1.5 is here, so it'll be a little less than that, maybe 1.3, maybe 1.2, kind of hard to guess. And then we have this. So what is your reasonable guess? The domain is, let's see, first interval, -infinity to some number a, bracket. We had abrupt beginning, so it should be bracket. This is my reasonable guess. Let's go back to the graph here. So -infinity to a here, and then we have empty space. So starting from b, not a, and then c somewhere here, that's vertical asymptote, and c to infinity, this one. And a value, it looks like -4. B value, it looks like +1. See? -4 and +1. But as for c, it's a little bit hard to tell. I mean, maybe 1.3 or maybe 1.2 something. This is just educated guess. This number here is not expected to be correct. -4 and +1, I'm reasonably certain, even though I cannot be 100% certain of anything unless I begin working on the algebraic expression. But -infinity to -4, I can see that. X-coordinate begins from 1 to some c, I can see that. From c to infinity, I can see that. Okay, so much for graphs, and we get this conclusion, or not conclusion, excuse me, educated guess, tentative conclusion. Let's go to the algebraic expression. We have two things to consider. Inside of the square root has to be non-negative, and then set the denominator equal to 0. From there, we have one vertical asymptote. Okay, inside of the square root has to be non-negative. That gives me a quadratic inequality, and the solution is like this. Is everybody happy with this? When did you learn quadratic inequality? We did it in chapter 4, I think. And one of the more common mistake was this. Do exactly the same as equation, like this. Factor, and then just like equation, x plus 4 is greater than or equal to 0. x minus 1 is greater than or equal to 0. So x is greater than or equal to -4, greater than or equal to 1, and then you got automatic 0. Remember, this is automatic 0. That's what I said in chapter 4, and that's how I graded in the first exam. This doesn't work. Inequality and equation are fundamentally different. One of better way to do it is right here. Draw the graph. Here's x equal to -4, x equals to 1, and then this entire expression has to be greater than or equal to 0. So greater than or equal to 0 here, above the x-axis. Greater than or equal to 0, above the x-axis. So x has to be either less than -4 or greater than 1. In the end, we get these two intervals. -infinity to -4, 1 to infinity. Now, let's bring this one back here. -infinity to -4, this one's right here, all set. Now 1 to infinity here, this one, and 1 to infinity is all here, but among this, there's gonna be a certain number pretty close to 1.3, not exactly sure which one just yet, that to be excluded. That's where the vertical asymptote is taking place. So this one gives me these two intervals, left, right, but this one is all set. The right hand side one, this green interval here, that's going to be separated by a vertical asymptote. Here, this one's all set, and that one here, they are separated by vertical asymptote. Okay, how do you get the vertical asymptote? The denominator must hit 0 there, so let's work on it. Set the denominator equal to 0, and oh boy, this is a radical equation, square root equation. How do you solve it? Let's go back to chapter 2. That's where we did all these. Isolate the square root and square both sides. So we have this complete square in the right hand side. In the left hand side, square root and square cancel each other out. So we end up with this quadratic equation. Remember this? We did it in chapter 2. It was hard problem then, it is hard problem now. But in any case, what is the purpose of this lesson, lesson 11a? Review and summary. Indeed, it's a review and summary. We just reviewed chapter 4. Now we reviewed chapter 2. And then from the final expression, we're getting 4/3 or x equal to 5. But then again, be careful here. How many vertical asymptotes did you see there? There was only one vertical asymptote, x equal to c, which will be determined. And x equal to 5, nothing there. So this got to be 4/3. Look at the graph here. X equal to 5, nothing there, no vertical asymptote. Around here we have vertical asymptote, that should be 4/3. So x equal to 5, that's got to be extraneous. Well, indeed, plug in those. Plug in x equal to 4/3 into this denominator and work out, you get 0. Yes, denominator is 0 at x equal to 4/3, so that's a vertical asymptote. When x is equal to 5, no, extraneous. So x equal to 5, no problem. You have to exclude x equal to 4/3 only. So from here, exclude x equal to 4/3. So separate the second interval by 4/3. There you go. 4/3, 4/3. The c value was 4/3. Does it match the graph? Yes, indeed. Right here, 4/3.